All right, this is What Time Is It Anyway? And my name is Tyler Jennings. A little bit about me before we get started. Again, my name is Tyler Jennings. I am a senior consultant with ResultStack. We are a consulting company based out of Knoxville, Tennessee, and we love to help people solve hard problems. We do a lot of customer facing transactional based software in all sorts of languages. Uh, if your team is looking for help on your next project, or maybe you're looking for a change, please contact me. I'd love to tell you more about what we do. Without further ado, today we are going to be discussing date time. And we're going to be taking a kind of a language agnostic look at the challenges of date time, some of the gotchas and problems, but not really diving into anything specific to one language or another. I'm kind of looking at you, JavaScript. But, you know, there's plenty of things that I've found that people aren't necessarily aware of, and this can affect how we write our applications. And sometimes there's a lot of misconceptions that are kind of passed around as always do this or always do that, and all your problems magically go away. And that's just not true either. It kind of depends upon what you're trying to do, what your goal is. So let's take a look at date time, and we will start out with a little bit of trivia to kind of highlight some of the lesser known challenges and problems with date time. So, first off, we're going to look at a scenario where a modern country in the last decade doesn't have a date on their calendar that everyone else has. So, Samoa doesn't actually have a December 30th, 2011. Again, this isn't ancient history we're talking about here. This is within the past decade. A country doesn't have a date on their calendar. So the story goes that in 2011, Samoa changed their time zone, their UTC offset, going from 10 hours behind UTC to plus 14 hours ahead of UTC. So they effectively went from the westernmost time zone furthest behind UTC to the easternmost time zone furthest ahead of UTC. Now, logically or logistically, this change made sense. Samoa does a lot of business with Australia and New Zealand. Every time ships or planes would travel back and forth, you would gain or lose an entire day traveling across the international date line. Also, Samoa wanted to benefit from bringing in extra tourism business because this change would make them the first place geographically to celebrate the new year. So they had multiple reasons to make this change, and arguably the change made sense from a business and economic perspective. The problem is more in how the change was implemented. So the change took place on December 29th, going from December 29th at 11:59:59 p.m. to December 31st at midnight, completely skipping the entire December 30th. Now, arguably, if they had made this change at any other time of the day, then December 30th would exist at least a little bit. But going from 11:59 p.m. on the 29th to midnight on the 31st, technically December 30th does not exist, and it would be invalid to have transactions on December 30th for Samoa for that year. So, I'm not sure how anyone solved that problem in Samoa. I'm not aware of anybody who had to actually deal with that one firsthand, but it does raise an interesting scenario where that date doesn't exist. Now, our next bit of trivia happened long before the modern technological era, and I'm very thankful for that. So, this is a country, Sweden, that has a February 30th. They have a day that no one else has. So we go from a country that is missing a day that everyone else has to a country that has a day that no one else has. The story goes on this one that as most countries were transitioning from the Gregorian calendar to the Julian calendar, between the 16th and 18th centuries, most countries would do this all at once. They would just skip, 10, 11 days or whatever and make the transition from one calendar system to the other calendar system all at once. For example, Great Britain made the change in 1752 in September, going from September 2nd directly to September 14th. Which kind of poses its own problems, right? You're missing a whole bunch of days in your calendar. Now, Sweden had other plans. The way Sweden decided to handle this is they said, well, instead of skipping, a bunch of days at once, we'll skip leap years for the next 40 years. And you could say, well, that mathematically makes sense, right? You will eventually get to the other calendar system by slowly skipping days, every 4 years. But it kind of poses another scenario where you are neither on the Gregorian calendar or the Julian calendar, but you're somewhere in between. Which kind of creates an interesting scenario that, doesn't just happen 1 year. It would last, 40 years until you fully transition to the other calendar. So that kind of creates its own problems there. Now, Sweden skipped the leap year in 1700. They started off the way they wanted to, but then, things kind of started to fall apart. War broke out. They forgot to skip the leap year in 1704. They forgot to skip the leap year in 1708. And, by the time they realized what had happened, they weren't exactly sure how to fix it. Because these two calendar systems aren't exactly in sync. So they decided, let's switch back to the Julian calendar, and we'll figure this out how to get to the Gregorian calendar, some other way. But in order to go back to the Julian calendar, they actually had to insert the missing day that they skipped in 1700 because they skipped the leap year in 1700. So what they chose to do was, instead of having an additional leap year like 1711, they decided to make 1712 a double leap year, giving it a February 30th. So in 1712, Sweden has a February 30th that no one else has on their calendar. Now, in 1753, Sweden finally made it to the Gregorian calendar the normal way by skipping 11 days. Talk about a nightmare. I'm really glad, we didn't have computers then, because that would be a headache to track. Now, our last bit of trivia has to do with the Unix epoch, or Linux time. Unix time, POSIX time, as it's called sometimes. Most people consider the Unix epoch, the start of Unix time, to be midnight, January 1st, 1970, UTC. Or is it? You see, UTC didn't exist until 2 years later, so to say that it was UTC is not actually correct. So some say, well, it was Greenwich Mean Time. Still wrong. At the Unix epoch, the time in London was observing British Standard Time, which actually wasn't introduced until 1968, 2 years before this. During British Standard Time, the UK didn't observe Daylight Savings Time, but instead they observed the equivalent of what would be a UTC plus 1 for that entire period, until British Standard Time was discontinued in 1971. So you have this 3-year period where London is observing this other time zone that, only was introduced 2 years before and doesn't exist anymore. Was discontinued a year after, where they're not observing Daylight Savings Time at all, and they are essentially the equivalent of a UTC plus 1, even though UTC doesn't exist yet. What that means is at the time of the Unix epoch, the time in London was not midnight, but 1 a.m. But To be fair, UTC is still a fair way to characterize this, as it is the equivalent of what it would be. But it was actually 1 a.m. in London at the time of the epoch. So enough of the fun trivia, little fun facts. Let's take a look at the core of the problem. We have to understand date time from the ground up to know what are the challenges that are posed, and how should we solve those. So to start out looking at the problem, we first have to ask ourselves, what calendar are we using? Are we using the Gregorian calendar? This is the international standard that most everyone is familiar with. But there's also a plethora of other calendars, including the Hebrew calendar, the Iranian calendar, the Ethiopian calendar, the Julian calendar, the revised Julian calendar, the Islamic calendar, the Hindu calendar, the Buddhist calendar, and many, many others. Many of these are used by different people groups around the world. Some are used civilly, not just as for religious reasons or something else. So if you're writing international software, depending upon your audience, you might have to interact with some of these other calendars. Now, the good news is if you know a date time and you know what calendar it belongs to, then you can easily and reliably convert to any other calendar system. The bad news is if you don't know what calendar system your date is derived from, then you can't actually convert it or compare it to anything else reliably. Let's talk about durations, the basic building blocks of our calendar. Let's look at days. Days aren't exactly consistent in length. Is a day 24 hours? Is it 23 hours? Is it 25 hours? Well, the answer is yes. If you observe daylight savings time, then at some point you have days that are, each of these lengths. The same is true with months. Months can range from 28 days to 31 days. And they're not consistent from year to year. Does February have 28 or 29 days? Well, it depends. Is it a leap year or not? But when you have inconsistent building blocks, that poses its own problem. Let's consider the .NET C# code here. We have a new date time, January 31st, 2020, and we are going to add 1 month to this date. If we add 1 month, what are we actually adding to this date? How many days are we adding? What does it mean to add 1 month? Is this 28 days, 29 days, 30 days, 31 days? Well, when we add 1 month, we will get February 29th, which is a difference of 29 days. Now you could say, well, we went from the end of 1 month to the end of the next month. True. But what happens when we try to do the inverse of this? If we take February 29th and we subtract a month, are we subtracting 29 days? No, we actually get January 29th, which is a difference of 31 days. So, first off, don't do any of your calculations by, add a month, subtract a month, because those operations aren't equal. You're not going to get the same result every time. And the same is true with years. If you think about it, years aren't consistent in length. Is it a leap year or not? Are we 365 days or 366 days? Now, enough of years and months and days. Let's look at daylight savings time. The good news with daylight savings time is that, well, you have more daylight during awake hours. The bad news is there really isn't any more daylight. It's just about perception. The really bad news is it's not standard. Not everyone follows it. Think about Arizona, for example. The majority of Arizona does not observe daylight savings time. Now, pockets of Arizona do observe daylight savings time, And pockets within those pockets do not observe daylight savings time. Kind of creates a odd situation. Sometimes with daylight savings time you are skipping an hour. Sometimes you are duplicating an hour. How do you store your data, your transactions, when you are duplicating an hour or skipping an hour? Can you refund a transaction before it happens? When you fall back, right? Those are things to think about. What about time zones? The good news with time zones is time zones create a standard time for a particular geography. The bad news is daylight savings time completely destroys that idea of a standard time. Also, rules for time zones can change. Whole geographies can completely change time zones. Consider the case of Samoa. Within the past decade, Samoa completely changed time zones to the other side of the world. That poses challenges. That poses problems. Also, it's worth noting that UTC is not a time zone. Time zones have to be tied to a particular geography, and UTC isn't tied to any place. Also, things like -0400, time zone offsets, are not a time zone. Time zone offsets make you think you know more about the time than you do, right? Let's look at an example. If we add 1 minute to this date, October 26th, 2014, at 1:59 a.m., -0400. If we add 1 minute, what time will it be? Well, it depends, right? In Knoxville, Tennessee, it would be 2 a.m., -0400. If you were in Cancun at this time, it would be 1 a.m., -0500. You see, when Cancun observed daylight savings time, they would actually transition about a week ahead of the continental US. So, saying this time is -0400 doesn't tell you anything about the rules that time follows. It just tells you, at that point in time, this is what it was, but that may not even be true from year to year, right? Cancun no longer observes daylight savings time. So, time zone offsets lead you to think you know more about the time than you do. So, don't make time zone offsets be your end-all be-all when knowing a time. Time of day. What does time of day even mean? Is that the elapsed time since midnight? Is that the elapsed time since the start of the day? Are those things even the same thing? Right? Some places, the start of the day is in the evening before. What about daylight savings time? Is 10 a.m. 10 hours since midnight? Is it 9 hours since midnight? Is it 11 hours since midnight? Well, yes, and yes, if you observe daylight savings time. Daylight savings time can be any of those. If you fall back an hour, you gain an hour. If you spring forward an hour, well, you lose an hour, right? So, what does that mean? In midnight, is that when the clock strikes 12? Or again, as we mentioned, is that, to the start of the day? Because some places, the start of the day is at sundown, right? Also, midnight doesn't always occur. You see, in Brazil and some other countries, daylight savings time transitions from 11:59 and springs forward to 1 a.m. And when falling back, goes from 12:59 a.m. back to 12 a.m. So how does that affect how you model all-day events? How does that affect, any cron jobs or, scheduled jobs you have on your servers? Is the clock actually going to strike 12 a.m.? Because in some places it won't. Now, in the continental US, most daylight savings time implementations go from 1:59 a.m. to 3 a.m. when springing forward, and from 1:59 a.m. back to 1 a.m. when falling back. So it generally happens around that 2 a.m. Time. So again, that's something to keep in mind. If you have scheduled jobs, is the clock on your server actually going to hit that time? Now, enough of the doom and gloom, and here's all the problems. Not even taking into account language, programming language problems. Let's look at some tips and guidelines for handling date time safely in your applications. The first tip I would say is do not store date times with a time zone offset. We already talked about, if you take January 1st, 2020 at 8 a.m., what time zone is that? It doesn't really tell you. It just says, well, you're 5 hours behind UTC at the moment, but is that Eastern Standard Time? Is that, Central Daylight Time? What time zone is it? You can't exactly tell that time in relation to anything else. You just know that, well, at that time, it was 5 hours behind UTC. It, might not always follow that. Do not store what you don't have or you don't know for sure. So don't try to guess the time zone. Don't say, well, this is -0400, therefore it must be Eastern Standard Time. Maybe, maybe not. Don't try to guess that kind of stuff. So only store what you know for sure. Do not store a date as a date time. If the time is unnecessary, leave it off. It can only cause problems later. Especially if you have systems that do conversions, sees a date and automatically converts it to, the time zone of the server or whatever, you could end up displaying the wrong date. It could assume, okay, well, this is, such and such time, and we're going to convert it to, whatever time zone, and now you've crossed a day boundary and you're displaying the wrong day. If you just need a date, store just the date, not a date time. On that same vein, birthdays are not a date time. I mean, yes, you're born on a day at a time, but generally we don't really care about the time. When we're working with birthdays, we care about two things. Is today your birthday? And sometimes we care about, well, how old are you? But most of the time we want to know, is today your birthday? And for that, we really just need the month and the year. Or the month and the day. If we want to know your age, then we need the year. But for these reasons, it's better to actually store the birthdays as separate pieces of data in the database. So have like a birth year, birth month, birth day. That way it's easier to write your query, hey, is the month and the day, are they today? Like, is that, today's month and today's day? Is it your birthday? And if you need to calculate age, you can always take the year and calculate age. If you need a full date column in your database, if your database supports computed columns, take those individual fields and, make a date out of the individual fields. But, you often sometimes too want to check, like, okay, get me everybody in the database that has, a birthday of this month, right? Maybe you're doing, any sort of birthday-related queries. Sometimes you just want to know, okay, here's all the people with birthdays in January, February, March, April, so on. So it's often easier to work with birthdays with the individual pieces. Kind of going back to what we said earlier on, don't take guesses. Don't make assumptions. Never assume that, well, you know what, we don't actually deal with transactions around daylight savings time changes right now, so we're never going to do that, because you don't know if you're never going to do that. Don't code yourself into a corner that you'll regret later. Also, never assume that the time zone rules or the daylight savings time rules won't change, because they do change, and they change more regularly than we would like to admit. Also, don't assume that a whole region won't just change time zones. Look at Samoa, less than 10 years ago, completely changed time zones. This kind of stuff happens. Um, so don't make assumptions around that kind of stuff. Store all the data you have about a date time. Now, this one is a little bit trickier because it doesn't mean the same thing for every situation, right? For historical times, it is often deemed safe to store a date time in UTC. Convert that to UTC, store that in the database. The reason being, if rules are going to change, rules change for times in the future. They don't really change for times happening right now and in the past, right? So it's often safer to use UTC. Let's consider this example. I used to work for a company that ran call centers all around the world, 24 hours a day. And so you'd have definitely transactions happening, around daylight savings time transitions. Let's consider the example where someone is on the phone at 1:45 a.m. And remember, most daylight savings time transitions happen at 2 a.m. So they're on the phone at 1:45 a.m. before falling back to end daylight savings time. The call lasts 30 minutes. 30 minutes later, the clock on the wall will read 1:15 a.m. due to falling back an hour. How do you record how long the call lasted? Well, this is where UTC comes and saves the day. If we convert those times to UTC and store that in the database, we would record that the call started at 5:45 a.m. UTC time, which is 1:45 a.m. Eastern Daylight Time, and it ended at 6:15 a.m. UTC time, which is 1:15 a.m. Eastern Standard Time. So by using UTC, we can accurately record, this is the call start, this is the call end. We can calculate the duration. This was a 30-minute call. UTC is made to solve this problem. If we consider the same thing, but when springing forward to start daylight savings time. Again, the call starts at 1:45 a.m. Call lasts 30 minutes. 30 minutes later, that clock on the wall is going to read 3:15 a.m. How do we record how long the call lasted? Again, UTC. We would record that the call started at 6:45 a.m. UTC time and ended at 7:15 a.m. UTC time. That would be 1:45 a.m. Eastern Standard Time and 3:15 a.m. Eastern Daylight Time. But UTC, removes the ambiguity and makes it really easy to calculate that call duration. I have at my tenure there, I saw applications that did not use UTC, and when we had a daylight savings time transition, there would be a developer staying up to make sure, okay, any calls that span that time actually get recorded correctly as far as duration and details and whatnot. And UTC solves this problem. I don't want to say UTC solves every problem, but UTC solves this problem. Times right now and in the past, timestamps and stuff like that. UTC is a great solution for that sort of thing. But as I said, storing all the data you have about a date time means different things for different situations. For future times, it may not be safe to use UTC. It might be safer to store that date time in the local time zone in the database, but also store the time zone. Not the time zone offset, not negative 0400 or something like that, but something like Eastern Standard Time or America/New York, depending upon the time zone database that you're using. So if you need the date time in UTC, then again, if your database supports computed columns, use computed columns to make that calculation. But store the actual date time as the time zone with the time zone, and that way you know how it relates to anything else. So this idea that, well, just use UTC for everything, it solves all your problems, is not true. I mean, it's UTC solves, timestamps like right now and historical times in the past, great. But UTC is not going to solve every problem that you have. Let's consider this real world example here. In Knoxville, Tennessee, daylight savings time started in 2019 on March 10th, moving from a -5 hours to a -4 hours. Knoxville ended daylight savings time on November 3rd, 2019, moving back to -5 hours from -4 hours. On April 30th of that same year, in 2019, the Tennessee House passed Bill 247 29-1 that would put Tennessee permanently on daylight savings time. The catch is if the federal government will ever allow that. You see, right now the federal government doesn't allow states to go to daylight savings time permanently. You can choose to not observe daylight savings time at all, or you can choose to observe it, part of the time, but you cannot be on it full time. Now, the real kicker is 18 other states have already passed similar legislation. So there are 19 states right now that are ready to go permanently to daylight savings time, if ever given the opportunity, permanently, full time. That means 19 states are ready to change their time zones. They're just not allowed to at the moment. So this isn't a hypothetical, well, what if our time zones change? This is, states are already trying to do that. They're just not allowed to yet. So let's consider the example where we want to plan a New Year's Eve party. Let's, say we're planning this New Year's Eve party December 31st at 7 p.m. We're going to do it in Knoxville, Tennessee, just as an example locale that, wants to make this change. And let's say on the premise that, somebody tells you, well, just use UTC. UTC solves all your problems. We convert this December 31st at 7 p.m. to UTC, and we store it in the database. And we do that in August. We're planning several months in advance. Well, when you convert that to UTC in August, your computer says, well, I know that, in August we're observing a -4 hours, but in December we observe -5 hours behind UTC. So I'm going to go ahead and add 5 hours to this, 7 p.m. to make it UTC, because that's what the current rule set says. So when you do that, you actually get January 1st at midnight, UTC time. Now, if November comes and Tennessee is allowed to stay permanently on daylight savings time, which means they're going to stay on -4 hours instead of transitioning to -5 hours. Do you start to see where this becomes a problem? We already converted this time based on -5 hours. Our computers did that automatically when we converted it to UTC. But now that rule is no longer valid. But we've already done the conversion. So when we pull that, January 1st midnight back out of the database and we convert it back to the local time zone, we now get 8 p.m. instead of 7 p.m. based on the new rule set. What's worse is if, maybe you just have an API that's pulling values out of the database and passing it down to the client in the browser and letting the browser do the conversion. If some people's computers have the updates, they're going to see 8 p.m. If they don't have the updates, they'll see 7 p.m. Right? So, this is a very real situation, that we're in, where lots of states are ready to change their time zones. Any future dates can be affected. So, it can be safer to store that date time in the local time zone and store the time zone information. Not the offset, but the actual time zone, right? And maybe the time zone version, of the database that you're using. So if you're, using a time zone database, which I highly recommend, they have different versions. You can say what version you made this conversion with, or what version was valid at this time. So that way, if it changes, then there could be something different. If you need that date time in UTC, then use a computed column if your database supports it. So this kind of brings me to the point of you might need to ask your users for their time zone. You can try to detect this automatically in the browser using the international datetime format .resolvedoptions.timezone. Most modern browsers will resolve that correctly. If you needed the calendar as a side, you can also use this .resolvedoptions.calendar to get the calendar. But ask your users for their time zone if you need it. Always use a known time zone database. There's two main databases you can use. If you're on Microsoft products, kind of in the Microsoft world, there's one included in Windows, there's one in Microsoft SQL Server. These are generally updated every 6 months. So that can be a great option. If you're doing a lot of cross-platform development, it may be better to use the Ionic time zone database, which is a third party, and they update their database a little bit more often. In 2019, there were 3 versions of the database. So far in 2020, there's only been 1 version of the database, but they tend to update it as needed and not just every 6 months. So why use a time zone database? Well, that's because things change regularly and sometimes without much notice. So Argentina gave 11 days notice for their decision to cancel daylight savings time in 2009. That's less than 2 weeks. In 2011, Turkey gave just over 2 weeks notice it was delaying daylight savings time by a single day. In 2013, both Morocco and Libya gave less than a single day's notice before changing their time zone rules. We would like to think that, as complex of a subject as this is, that there are a lot of smart people working with governments to plan these changes far in advance. But that just doesn't seem to be the case. So use a time zone database and try to stand on the shoulders of giants that have they're compiling this information and trying to stay on top of things. So it's much easier to do it as a community than to do it on your own. So you may store those future dates in your database with 3 columns: a local time column, a local time zone that might hold something like America/New York if you're using the Ionic time zone database, or Eastern Standard Time if you're using the Microsoft database, and then maybe a local time zone version, such as for the Ionic time zone database, it'd be 2019C or 2020A, something like that. Always use a library when working with datetime. Never try to write your own datetime library or framework. They are insanely complicated. So use something like Moment.js for JavaScript, or Notatime for C# or Jotatime for Java. Or I'm sure there's plenty of other great libraries for other languages out there, but this is a complicated, complex subject, and you can't, handle everything yourself. There's a lot of smart people that work on these libraries. Not that you're not just as smart, but working as a community, it's easier to build a solid set of tools. So always use a library. Now, my last topic for today is POSIX, or Unix time. There are people who tout POSIX as better than the Olson datetime format. Just like there are people that always say, well, just use UTC and your problems go away. That's not true either. But POSIX does have some strengths, but it also has some weaknesses. So, you need to be able to make an informed decision on whether POSIX is right for you. So with POSIX, datetime is represented as a string in numbers. And here we have 15778836, and a bunch of zeros, and that is the equivalent of January 1st, 2020 at 8 a.m. Eastern Standard Time. There are some languages, such as the Elmlang, that change their default implementation for datetime to POSIX. So there are people out there that really like POSIX. IBM is another company that really likes POSIX. There are benefits to POSIX. So with POSIX, you can override time zone and daylight savings time information manually. That can be very beneficial, especially when there are such short notices for changing time zone rules. Also, if you're on Linux or Unix systems, you don't have to load a file for every time zone like you would if you were working with the Olsen time zone, an Olsen datetime format. So there's a little less overhead if you're using POSIX. But that doesn't mean it's a silver bullet or a panacea that solves all your problems. POSIX has Y2K coming up in the year 2038. So some systems are still using signed 32-bit integers for POSIX. And, well, those numbers are going to roll over in 2038. MySQL's database functions like Unix timestamp will return 0 after 3:14 a.m. UTC time on January 19th, 2038. Now, there's plenty of time to get that resolved, right? It's not like it's down to the wire here, but just know that even if you're converting times, future times to POSIX, after 2038, you're not likely to get the result that you expect. As a fun fact, the network time protocol NTP has a similar issue where time will roll over in 2036, back to January 1st, 1900. Also, POSIX is not great for database indexing and data warehousing. If all your data and your timestamps go into your database in order, and your indexing doesn't really have to move, reorganize the data, then fine. But if you have data coming in from several sources, or just data going into the database, and out of order, and your database has to index those, it's much harder on the database to index POSIX values, because if you look at the example here, we have two times. Both are January 1st. One is 8 a.m. and one is 5 p.m. And in POSIX, there is a difference of 32,400,000 for just those 9 hours. Think about your database having to index that. That is not a pretty sight. So don't use POSIX where, you really have to do a lot of, data warehousing, or your database has to reorganize the data, because it's just not going to be very efficient. A pro tip, if you're doing, massive amounts of data in your database that you're having to index, it can actually be better to break dates out into separate columns of year, month, day, maybe even hour, minute, seconds. It can index those columns individually much, much more efficiently. So don't choose POSIX if you have a lot of database indexing or data warehousing needs. Also, POSIX has the exact same problem with future dates that we talked about. Because essentially, as we started out with in the trivia, POSIX is essentially the time elapsed since the Unix epoch, which, January 1st, 1970, UTC time, midnight UTC, or 1 a.m. in London, right? But you are essentially taking a UTC time and putting it in numerical format, and that is essentially POSIX, right? Because you're based off of a UTC start value. So, if you have a future date and you're using POSIX for that, then guess what? You put that date in there, and time zone rules change or whatever, you may not have the correct value anymore. And one downside is with the POSIX format is it's not really human readable. You can't look in the database and see, oh yeah, that time is off an hour, right? So just be aware of that. There is no one right or wrong way to deal with dates. There's a lot of varying situations. Everybody's building their applications with different goals in mind. You know what your needs are and what kind of data you have. This is really just meant to say, here's the shortcomings and here's some challenges in dealing with date time, and here's some ways that you can solve some of those challenges. There is no always do it this way and all your problems go away. That just doesn't happen. Date time is a complicated subject. So take a look at your applications, take a look at some of these challenges and some of these solutions, and see what works best for your situation. There is no one right way to do it. Here are some links that you may find useful. This first link is the Ionic time zone database. The latest version at the time of this recording is 2020A. The second link there is where I got some of the trivia, and that is from the Notatime website. The third link is an article by John Skeet on why UTC is not a silver bullet. John Skeet is a much bigger authority on this subject than I am. I've actually learned a lot of what I know from him. So check out that article and check out other articles he's written on date time. He is very knowledgeable. He also works on the Notatime team, so he has a lot of hands-on experience with a lot of problems that most of us probably don't deal with on a day-to-day basis. The next article there, the fourth one, is an article by IBM and Red Hat on POSIX. The two articles after that are the Wikipedia pages for POSIX and the year 2038 problem. Some interesting stuff to read about there. And then the last three links are the websites for C#'s Notatime, Java's Jotatime, and Moment.js. And I'm sure there are many other great datetime libraries out there. Those are just three that I've had some experience with. So if you use those languages, check them out. They're very helpful. So if you've made it this far, thank you. I hope you have appreciated this talk, and hope you learned something and it makes you think about your applications in a new way. If you need to reach out to me, you can always email me at tylerj@resultstack.com. Thanks.